code, working code, for the 1D cluster variation method, or 1D CVM. We've got it available, and there's a example that you can play with so that you can get firsthand an understanding of what's going on with this method. Please go to the Themesis blog post associated with this YouTube. The link is in the description box. The blog post has all sorts of links, including the one to the Themesis GitHub repository. Take the last code that you see. I believe it's the 1.5.5 code that you'll want. It is so simple and easy to use. Copy it, plop it straight into any Python idle environment. We're using Spider. We're using Anaconda Spider. It is as simple as can be. And just plop it in, hit the run button, and it will run. No need to install data directories, nothing fancy. 3 sections for that code. The first thing it's going to do is compute the local configuration variables for each of the nodes in that 1D CVM. The second thing it's going to do is ask you to identify 2 nodes that you want to swap. They have to be in different states, one on, one off, one black, one white. I typically use the 0, 0 node, first row, and the 0, 3 node. The 0, 0 node is black, the 0, 3 is white, it's the first white node, and so when I'm interacting with that code and it's asking me to identify the 2 nodes, I just type in 0, 0, 0, 3. Easy. You can play with all sorts of combinations. They just have to be different kinds of nodes, one on, one off. Once you do that, it'll compute a new set of local configuration variables. Then it will give you the fractions of configuration variables of each type, and of course for each kind of configuration variable the fractions sum to 1. You'll see that works. And then it computes the entropy for the original and the entropy for the system that you just modified. And you will find that no matter what you do, you're going to be increasing. That is, pretend that this is our negative entropy right here. Right here at the bottom is where we have the negative entropy for the system that I've put in there. And it's designed to give you the lowest possible entropy, lowest possible negative entropy. And then when you make a change, it's going to move it up one way or another. It's going to move it off that negative entropy minimum. This is the first time there's been code available at all where you could play this kind of game. To the best of my knowledge, there's been interest in the Kikuchi cluster variation method in Japan sporadically. Various scientists have applied it to studying metal alloys, and that's not too unrealistic. Ryoichi Kikuchi was Japanese, and he influenced some of his colleagues there who've used his method. Following some work that I did, Professor Carl Friston asked a couple of his students to work on a cluster variation method approach for their master's degree projects. I've referenced that in the various blog posts, and I'll put a link again to their work in the blog post for this vid. It's good work. You just can't play with their code the way that you can with this. It's not giving you that opportunity to interchange nodes and see what happens to the entropy term. So this is a first step for us because it gives you hands-on experience with that cluster variation method. And now as we start to talk about what it takes to model the free energy, and specifically the entropy, for a system of latent nodes that are dynamic and interactive with each other, now you can go hands-on and experience this for yourself. So thank you. We look forward to seeing you. Please do opt in. Themesis website, about page, scroll down, opt-in form, opt in. That will let you know when new things like code releases are available. Thank you for joining us. Once again, Aliana Moren from Themesis. Have a lovely day.